Okay, we've been cruising. Now we want to see if people are with us. We've been taking it a little bit too slow. We've been doing 1-2 minute videos. I don't think that's nice. I'm gonna look at two cases now. We've looked at the end, we've looked at the O, and we've looked at the what? At the end. Now what I'm gonna do, we said our O was a parallel set of contacts that drove our output, and we said our end was a series set of contacts. Okay, now let's name this x0, x1, x0, x1. Can you do this? Yes, we've been doing this. We've done this before. X's can occur as many times on the input side as possible. No harm there. Can we, however, say Q0? Q0? Nope. Why? Because we have got conflicting instructions driving Q0. Most PLCs will declare that as a what? Will declare that as a conflict there, and therefore they will what? They'll tell you have an error. So there is a situation where it's either or and. Remember, it's very stupid actually to say that. Okay, what I mean here is different statements that probably are opposite to each other, conflicting statements driving the same output. Because remember, this actually includes the AND statement anyway. Remember, when you got 1, 1 there, it's as good as the AND statement. That's why we call this the inclusive OR. Let's be very careful about some of these things. But what I'm trying to say is avoid having Q's repeated on the output, because you could have conflicting instructions trying to drive this through, and obviously if they are conflicting, the output will also be confused. So avoid, at any cost, try and avoid repeating the output from different instructions, from different ranks. All right, so let's go on and say, how then do we do the no? Can we do this and get the no? Perhaps. Or can we do that and get the no? Let's look at this. If we say, if we don't touch any of these, that run is true. Therefore, Q0 is equal to what? Q0 is happy. Alright? But if we touch any one of them, if we energize any one of them, for you to get power, you must neither energize X0 nor X1. So this here is actually our NOR gate is derived from the AND, not the what? Not the OR. So this here is X0 or X1 not. Alright. Obviously now you can see, can I break this? Yes. I will still have power from that. Can I break this? Yes. I will still have power from that. Can I break A and B and still have power? No, I may not break both A and B. So this will be what? This will be X0. I'm saying A and B, and it's X0, X1. This is our NAND. I cannot break XO and. So once I say not and, I'm talking about what? The NAND gate. So these two are what? But obviously you would have the one. You would have this here. You would have the one. Okay. You would have the one. I'm taking time wasting it. Now this is your what call this? Your NAND, or you would have the other one being your NOR. Alright, can you have them in the same space? Of course you would, but because to avoid conflicts, you would name these different. That would be Q1 there, implying therefore that Q1 is the NOR. Okay, yes, you cannot have. Can I have? Is there a way of me having what? Having driving one output with different scenarios? Yes, obviously there is, but not this way, because this way will cause what we call an internal conflict. It will look like there's different instructions driving the same what? The same output. So you will need to avoid having the same output twice. All right. Oh, I remember we said we are doing the NOR and the NAND. So this was our NAND. That there is our what? Is our AND. I hope that was not confusing. I don't think it was. Might have been a little bit too fast at some point, but hopefully we